What is up, most distinguished patrons? Now is the time that I can finally spend some time and we can go through and do a deep dive into this Vulcan TIG 165. So with that said, let's get into it. So some of you may know that I bought this a while ago, and probably most of you don't know that. And I thought, well, I wanted to get into it right away, and then guess what? It sat in a tin shed in a corner for like, I don't know, 3-4 months or something. And I didn't get around to using it, to looking inside of it, doing a video on it. Well, today's the day. What better day than today, I guess. So anyways, what we have here is the Vulcan TIG 165. Now, I normally wouldn't buy this because, well, I got a Miller Dynasty TIG welder and that works perfectly fine. But there's a couple of reasons why I bought this. One of which is I've never seen the inside of a Vulcan brand welder, and I thought that, hey, why not open this up, see how it's built, see if it's cheap, see if it's made out of decent components, get an idea on that, because Vulcan welders are popular with a lot of you guys out there. The other reason is that I'm actually going to be giving away this after this video. It's going to be, I don't know, 2 weeks, maybe a little bit more, right before Christmas as part of my parting gift for the How to TIG Weld series. Now, realistically, I'm not going to be done with the How to TIG Weld series. My plan was to get all the videos I wanted to done on that before the end of the year, and that's just not going to happen. Like everything else, it takes time. So I'm just going to give this away still before Christmas, so stay tuned for that. If you're not subscribed, guess what? To see that video dealing with the giveaway, you're going to have to be subscribed. So anyways, the reason I bought this particular welder was because it was an open box. It was marked at $255, and I actually bought it because they had some deal going on open boxes for something like 170 bucks. And like with everything cheap, there's always a catch. And in the case of this, it wasn't a venereal disease. It was that I was missing some parts. So what I got for something like 160, 70 bucks was the unit itself, one power cord, which this happens to be the 120 volt power cord, no TIG torch, and no foot pedal. So it's not that great of a deal at that point. However, what I ended up doing was, obviously I got this machine. I bought the foot pedal separate with a coupon, which cost me somewhere around, I think, 70 bucks with a coupon. I don't remember, under 100 bucks. So I'm in it for like 260 bucks at that point. And then I bought this TIG torch through HTP America USA Weld. That's who I generally buy all my TIG torches. They're good guys over there. And this is far better than any torch that the machine would have came with. There's no doubt about that. And it's a flex neck, which I prefer. So anyways, I still have to get the 240 volt power cord. And realistically, I'm just going to probably make my own rather than buying it from them. But all said and done, I'm in it for less than $400 for a better setup with a better TIG torch than a box stock one. So is it worth it? Well, yes and no. I mean, I guess these things have an okay warranty if you buy it new, but I think they sell between $500 and $600. So I'm in it for less than what it would have cost to buy it new. So I think it'll work good. And truth be told, all I've done with this was plug it in and make sure it powered on. I've actually haven't welded with it at all, so hopefully it welds. I know it turns on. But to start things off, I thought we would take a look at the overall build construction on the exterior of this, and then we're going to tear this apart. So let's start looking at that. So the first thing I noticed is that the build quality on this exterior-wise is better than the titanium line, and this is going to be better than most of your Amazon specials. Like the carry handle is really nice, rigidly mounted. The plastic doesn't feel as cheap. What does that really mean? Well, not a whole lot, I guess, at the end of the day. One cool thing about the front of this machine that I wish other companies did is the power switch is on the front and not on the back. I don't understand why, with modern technology, that the power switch is always in the back of a machine. Because if it's in some rack or on a welding like cart or something, like who wants to reach behind there to power it up? Put it here. So I'm kind of surprised they put it there, and I appreciate that. That's a nice detail. Not even my $5,000, $6,000 Dynasty could figure that one out. So that's nice. Now, this uses DINS 25 connectors, which normally I would like to see the DINS 50, or they're called 3550, the bigger 3/8 style, not the 1/4 inch. The reason I would like to see those, one, they handle more amp capacity, and two, they're just firmer locking, I find. However, the nice thing with this is this uses gas through DINs, so this does not have a separate cord to hook up or a separate hose for gas flow. You just put that in there, tighten it up, and that's it. I appreciate that on super small portable welders because it's one less hose you got to dick around with that you need like quick connect fittings. So that's nice. And because this is only a 165 amp machine, I know that these DINS connectors are going to be okay at handling that kind of amperage, and I'm not too worried about that. If this was like a 200 amp machine, you wouldn't want to see these DINS connectors on them, and that's what most Amazon specials have, and they're really overloading them. So for the use of that, that's okay. Now, the foot pedal hookup, I'm not sure if it's a standard. My guess is it's somewhat unique to this or other imported welders, so good luck using your Miller Lincoln ESAB foot pedals for this. They're not going to be compatible, so you need to use their foot pedal, which that is what it is. Normally this would come with it. I had to buy it separate. So the back of the machine has your common gas hookup. Now this kind of has a chintzy nut on there, kind of like what you'd find with electrical conduit. And you know what, that's probably fine as long as, you know, you don't go over tightening this like a bear, and then when you back it off, it ends up spinning in there. So I wouldn't worry too much about that. At least it is retained. I've had issues with cheap welders where these suckers are loose and then you end up spinning the solenoid or something inside. Kind of annoying. Now this uses a 250 volt is what it's called plug. And that's kind of, I don't want to say common with welders like this, because a lot of them have a built-in cord and then they change this with an adapter, well, the 240 version of this, to make it 120 volts. This instead just uses two different cords. Both of them have the same pinout, it's just this end is different. So that's why I could just get a plug like this and make my own 240 volt cord for probably 20 bucks, which is less than Harbor Freight probably charges for a replacement, which that is available in a replacement. I looked on their website. Other than that, this has a big giant like computer PC fan back here. I like seeing this, and the reason is that if it had one of them small high RPM ones, it would be loud and annoying as shit, and I can't stand a loud welder fan. If you have some 350 amp machine and you're arc gouging, I get it. Like, that's the least of your worries. But on a small, portable, precision TIG welder, that's not something that I really care for. I want it to be reasonably quiet. This does appear to have fan on demand control, so this only runs when it's needed, and I appreciate that. And we're gonna find out for sure, but when I powered it up, it seemed like the fan shut off initially, so I think we're gonna be good in that respect. One of the telltale signs that you're dealing with at least a reasonable piece of equipment is the data plate. And they took the time not only to put this on here, but it has a lot of pertinent information that kind of gives us an idea that at least some kind of give a shit or caring went into building this. And what I mean is when you look over here, it says it conforms to UL standard. Now it doesn't say UL listed, but at least it says it conforms to it. That's something that you probably won't find on a, Amazon special welder. So that alone gives me at least a little bit of a vote of confidence that this isn't gonna melt down and burn your garage or house down. This also is CSA stamped. That's also a good sign. So those right away, that's good information. Over here, it depicts how this device more or less works, where it talks about single phase AC comes into more or less a IGBT module, or a module that controls frequency and voltage, and or one or the other or both, into a transformer, and then a transformer's AC output is rectified to DC, and it has DC output. So that's again a good sign they at least have some kind of electrical knowledge in this. It does say IP21S, which probably is pretty low on the scale. Now, beyond that, it gives a lot of information that can be useful to determine certain things, like, for example, duty cycles. 100% duty cycle, meaning you can weld nonstop, is 90 amps, and this is on 240 volts, by the way. So that's a pretty low amperage output at 100% duty cycle, but again, that's within the realm of what the smaller welder would really be used for. I mean, you're not going to be doing big, 200 amp aluminum jobs on 1/8 inch or 3/16 all day, because this is DC. So that's not too out of the ordinary. Now, 60% at 120 amps is pretty decent actually for this small of a unit, and then at 30% duty cycle at 165 amps. So that is, I would say, honestly, not that bad for this small of a unit. Now keep in mind, this is small, but it's not as small as some of the other 160 amp machines on the market, so that might be part of the reason why they're able to get an okay duty cycle out of it, is the components in here are probably a little bit beefier than what you'd normally find in a small unit. Now, that's TIG output. On stick output, 100% at 90 amps, 60% at 120, 30% at 165. Now, what I find funny about this is technically stick operates at 26 volts instead of about 16 to 17. The fact that this is labeled with the same duty cycle for both stick and TIG tells me that they're underrating the TIG duty cycle significantly, because it takes far less power and generates far less heat at 165 amps a TIG. And if that is a correct duty cycle for stick, my guess is the duty cycle at this max output's probably closer to 50% for TIG. So kind of interesting. We're not really going to test the duty cycle, but I'm sure it's going to be accurate to what's on here. Now, on 120 volts, there's a significantly lower duty cycle, and that is, again, to be expected. It's 25% at 130 amps, but keep in mind that would be, it's more or less its max output on 120 volts. So you have reduced output when running on reduced voltage for the input. Again, all typical things. And the rest of this, we'll just quickly go through some of this stuff. It says its inrush max is somewhere around 14.7 amps for TIG and 22.4 for stick. That sounds plausible because it's only a 160 amp machine. That isn't too unreasonable. Now, nowhere on here does this say it has power factor correction, nor does it claim what the power factor is. So we'll have to test that. What's interesting is on 120 volts, it basically pulls roughly the same amperage at the reduced voltage, but again, you're getting reduced output. And something I didn't mention is this machine's probably limited to 90 or 100 amps on 120 volts for stick, so much more reduced stick output. And again, this is actually a good sign, because a lot of the cheaper welders out there, they don't regulate the stick output on 120, so you're just going to pop the breaker in your house trying to stick weld with it. So again, all good signs. Now, a couple other things of note with this. Like I said, they don't claim that it has power factor correction. I wouldn't imagine that it would. If it does, we'll find out, and that would be a great thing, because it's basically not going to trip breakers running on 120 volts, at least less likely. So hopefully it does, but again, I don't expect that. The other thing I'll mention is nowhere do they claim that this will run 6010, and I have a pretty sneaky suspicion that it will not run 6010 rods for stick, and that is because most inverter welders that are 120 volt compatible typically do not run 6010 because of the excessive voltage that's required. And I'm not going to go in a lot of detail about that, but needless to say, 6010 needs 31 to 35 volts to operate at, and most inverter welders can only output maybe like 26 to 28, maybe 30 volts, especially on 120, and that's why they won't run it. You'll start the rod and then all of a sudden the arc just goes out. Very typical. So I don't expect 6010 capability with this, but we will test it just to find out for sure. Oh, and when I bought this, it didn't come with any stick leads either, but I have a set, so that's what I'm going to use for this. So anyways, I'm gonna get set up and start taking this sucker apart so we can look inside and see what you get. So this is a significant departure from what I have seen inside of Harbor Freight's welders, because I've opened up the titanium 225, I've opened up the titanium 125, and I've seen, of course, the Chicago Electrics and all of those. And this is the first Vulcan machine I've actually seen the inside of, and this is, like I said, a departure from what I'm used to seeing. So the first thing that jumps out in front of me is the way that they did this cooling system. So more or less the fan likely pulls air in from the front and then sucks it through here out back, or actually, judging by how this is done, maybe it pulls it in from the back, blows it through. The interesting thing is that that's considered like a wind tunnel design, and that's a good idea because it keeps the grinding dust mostly on like the heat sinks and stuff, and it blows it out of the machine rather than having grinding dust sit on all the components and possibly shorting them out over time. So that is a massive departure from a lot of the other designs. If you remember, and I'll put a picture of it up right now, the titanium 225 was more or less more of an open design without the wind tunnel to this extent. So that's a good sign. The second thing that jumps out at me is the components. A lot of them seem to be marked name brands, about 50% of them. Another 50%, so about the other half, let's keep it simple, don't appear to have any name on it. So that's at least a good sign that some of the components are some names, brands that I recognize. Now, one of the things I've learned about Harbor Freight, and this goes with kind of really all electronics, is that there's running changes over time. And what you'll find is if you open this one up and then one that was built 2 years newer or something, that oftentimes they are different internally. The titanium line specifically, I've opened up probably 5 of the titanium 125s, and every one of them is almost like a different welder internally. So I find that kind of fascinating that they could have that much running changes, or just simply multiple factories making it, and as long as it met spec, you're good. But the crappy thing is that if they're changing that many components, then you might have one you like the way it welds, you buy a different one that says it's the same and it welds completely different. So that's kind of bogus in that sense, and I don't know how many running changes Vulcan has done. I don't really see anything other than version 1 on any of these boards. So, or well, this says version 1.1, that's the only one that says that. So I don't think that this has had too many revisions since it was made. Now, truth be told, I'm not sure if they even still make this unit anymore, because it probably didn't sell that well because everyone bought the ProTig 205 or whatever it was called. So they might not even make this anymore, but it is what it is. This at least gives us an accurate representation of this machine. Now, being that this was an open box, obviously that probably means something was wrong and it was returned. And looking at everything in here closely, I don't see too much evidence of stuff being repaired or replaced. Like this board appears to be untouched because the plastic screws would have showed damage. This board down here, which appears to run the LEDs and stuff on the front panel and control the amperage via the dial, that appears to be untouched. However, whatever this module is here that the power wires feed into, and I don't think this is the IGBT module, I think that's lower. This might be a full bridge rectifier setup here, possible. I'm not sure on that. The screw on it is damaged, and I noticed that the heatsink goop has a line down it. I'll put a picture of it up right now that shows that this was pulled after it was put in place with all that schmoo on there. So I would be highly suspect that this module was bad and that they ended up replacing it and then basically selling it as open box to recoup some of their costs. Now, this module has no apparent part numbers on it, and I'm not exactly sure what it does, but it's either going to be part of the bridge rectifier system in this, or it's going to be part of the IGBT module, the inverter, one of the two. But anyways, to me, highly suspect. I'd almost guarantee you that was pulled out and replaced at some point, and that was the likely failure. Now, the good news is if that fails on yours, you might be able to get an actual replacement for that. It's just I don't have a part number or absolute certainty what that is, but at least it's accessible. Everything else in here for the most part is accessible. Now there's going to be bigger capacitors and other components like the main transformer all underneath here. I'm going to screw around with this for a little bit and see if I can't pull this up to where we can see any of that. Hopefully I can. So I removed a bunch of screws out of this, and I'm going to have to remove all these boards to kind of pull this out to get a better look. So I don't know, these are plastic. They're just going to end up breaking, I think. But luckily this fan is big enough that I think I can get a photo of the internals using my cell phone camera. So I'm going to put up a picture of that and just talk a little bit about it. So by the look of it in there, we have a conventional transformer, so it's not like a toroidal transformer, which might be a little bit more efficient, but that's not really a big deal. So we got a conventional transformer, a bunch of capacitors, a bunch of heat sinks, and I'm pretty confident that up here, what we're staring at is a bridge rectifier to convert the AC input into DC to feed into the IGBT modules, which are down in there with the heat sinks. So realistically, it's pretty simple of a design, but the nice thing is this wind tunnel design is probably going to give a little bit longer lifespan on these components because all that grinder dust isn't getting its way up to here and shorting stuff out. It's mainly in there at the heat sinks. And by the way, they did do a pretty good job on coating everything with like silicone that would be likely to short out. That way, again, the components will last a little bit longer. And the wraps on a lot of these wires are like high temp silicone. That's all really good attention to detail, I guess. So as expected, the build quality of this is going to be a step above the titanium series, which, let's face it, it better be for the extra money. Now, is this on par for build quality with ESAB or Miller? I would say no, or Lincoln, no, but I don't see anything that jumps out and says, Jesus, what were they thinking? So that's a really good sign. And like I said, this is clearly built better than an Amazon special welder. Now, there's a couple more things down here I want to talk about quick, and then we're going to deal with the most important part, how it welds. One of the things I kind of found fascinating, and this has a rather large one, is this unit right here, this component, which in the welder world is called a reactor, a welding reactor. And what it is basically a big mass of copper. Now it's flat bar stock. Under normal circumstances, it could even be made out of wire. And that's kind of more, I guess, old school to do a wire. But what this is it's a form of an output choke that helps smooth out the DC output on this. And what I find is a vast majority of cheaper stick welders don't have that. But if you don't have some kind of output reactor on a DC output welder and you want a TIG weld, you're going to notice that the TIG arc is not very smooth. Okay, with stick you don't notice it because stick will run on AC even. So a dirty DC where it's not like stable voltage isn't that bad, but the fact that they have one of these in here should mean that it has a pretty smooth and stable DC arc on TIG, and I like that they did that because if it didn't have that, I would probably see it in a TIG arc, and that's something that I've seen in a lot of cheaper TIG welders like off of Amazon that I've used. The DC arc does not appear to be as stable as you would expect. Is it serviceable? Yes. But again, with a higher end welder, you would expect, you know, a more stable DC output. Someday I'll have to do a video where I hook up an oscilloscope before and after this to show you what it actually does, because it's pretty neat. Very simple technology, but the fact they included that is a good sign. I like that. Also, the backside of this, even though it's a good ways away from actually touching the case, any kind of points that were higher that could have shorted out to the case, they put this silicone crap on it, which again is a good sign, because a lot of cheaper welders, they just put a piece of like non-conductive paper or plastic in there and call it good. Well, guess what? When you hammer on the case, like it gets a dent, it'll penetrate right through that paper into any part that sticks out, like a through-hole component, and then it's still going to short out. So that's a nice touch. Again, things that you would expect in a higher-end welder that you just don't see in cheaper welders. Now, does that mean this is going to last longer? No, but again, attention to details matter. So the last thing we're going to talk about is a little bit of how this functions. This has lift arc TIG, which I like that it can do that. It has high frequency, which if you want to get into TIG welding, honestly, you're best off getting a machine that can do high frequency. This has TIG pulse. The pulse feature is basically predetermined and it's not adjustable. I don't really find that kind of pulse to be that effective or useful, but hey, it does do it. And then of course it has stick mode. Now this machine, to my knowledge, has no arc force adjustment. So if you're running like 6011, which hopefully this will run, you can't adjust any of that. Again, this is sold more as a TIG machine that can happen to stick weld than a stick machine that can happen to TIG weld. Therefore, very minimal stick features. Amperage dial, very simple because there's no LCD display. It has an inner ring for amperage on 120, and then it has an outer ring for amperage on 240, and it's that simple. Now with TIG mode, you can use the foot pedal to throttle everything, so that's kind of irrelevant. In stick, you don't really need fine control anyways, so I'm perfectly fine with this design, and it should be more than serviceable. Now, the last thing I'll mention, I promise, the switch here, basically the main power that comes into the machine comes to this switch and then goes to the rest of the components. As with everything from Harbor Freight, they always seem to use cheap switches, and this switch, I'm sure probably isn't even rated for 240 volts, which a lot of the times I found that to be the case, but let's say it is. It's a cheap chintzy switch, and if you ever have a Vulcan brand welder, because I think more of them than this one use that switch, and it doesn't turn on, like you flip the switch and nothing goes on, my guess is the switch failed. Luckily, this appears to be somewhat of a box standard design. You probably can get a replacement, which is good. But I've had such bad luck with their switches that in every video that I talk about anything from Harbor Freight, I always gripe about the switches because it's true and you know it. So don't doubt me on that. All right, well, I'm going to get this sucker reassembled and we're going to start out with TIG welding and see what this will do. Well, unfortunately, I was not successful in making this more efficient. I had no leftover parts, but let's see if it powers up. Yeah, so it definitely has fan on demand. As you can see, the fan ramped up and then it shut off. It's about 55 degrees in here or so, so it's good that it's not running, and I appreciate that. Now, who knows, when I strike an arc with TIG, it probably will start immediately with the fan, who knows. But we're in high frequency TIG mode. I have a foot pedal for it. Like I said earlier in the video, I bought it separately because this one didn't come with it. The normal one does come with it. When I'm done doing some test welds, I'll show you the foot pedal and talk a little bit about that. But to start things off, we're going to run on 120 volts, somewhere around, I don't know, 80 amps, and we're going to weld some steel over here. All right, so I did a couple welds here. This was the first one and welded fine. And then of course the plate's preheated and I ran a little hot, little bit flat of a weld, probably excessive penetration in the back. Tried to make a smiley face here like an idiot and then, well, couldn't do the mouth of it. And then ran really cold to kind of get an idea of the low amperage capability of the machine. And I'll tell you what, I learned a lot just in this little bit of screwing around. So the first thing I can report is the arc starter on it is what I would call crisp. It's, I would say 20 amps or so. It pops pretty good. On super thin material, meaning thinner than this by a significant amount, you're probably going to blow through with the arc starter, but I don't see that as a negative because a vast majority of us don't TIG weld razor blade thin thickness material. This will blow through, but you can always take a bar of copper like this, set it close to what you're welding, start the arc, and then bring the arc over onto the material if you need to weld something super thin, so that's not really a big deal. Now, overall, this thing drops to probably about 5 amps, so it has really good low-end TIG. Down here, I mean, I was barely on the pedal and it almost didn't want to make a beat on this. It was so low on amperage. Now, I also noticed that it's, how do I put it? Arc stability, the smoothness of its arc when you rapidly change amperage is not as smooth as what like my Miller Dynasty is, but let's face it, that's a $5,000 TIG welder versus, you know, 500, so we wouldn't expect that. But what I find is, I don't want to say it's unusual, but if you rapidly press the pedal or you rapidly come off, it's almost like it's adjusting in 2 amp increments rather than smooth. The good news is that when you slowly press the foot pedal or slowly back off of it, that is incredibly smooth. It's just rapid changes is not as smooth as some of the other TIG welders on the market. Again, higher end ones than this. So I figured I'd show you what's going on. If you listen closely as the arc ramps up and down fast, you hear ticking. That's the arc actually jumping like an amp or two. But luckily, they got it dialed in for the slow pedal control that it doesn't jump. And that's something I've been somewhat critical on certain ESAB welders, is that their arc is not smooth when you're really slow and you're backing off. It's like click, 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 click. It's almost adjusting in steps. Luckily, this does not do it. So I would say its DC arc is extremely good at the fine control, not so good at like more coarse control, and a little bit hot of a start. So that's all things to consider. But honestly, for the price, I would say it's pretty frickin' good, surprisingly good. So that's great. Now the fan is definitely on demand. It kicked on when I was welding and then shortly after kicked off. So it's not so much based on thermal likely. It's just going to run anytime you're welding and then shut off, and that's what I like. I don't want it to run all the time. I find that annoying. Now, another thing I noticed with this is the post flow is kind of excessively high. And what I mean by that is when I finished welding, it's still allowing argon to flow for, I bet, 10 seconds, 7 to 10 seconds. That is a very long time for post flow at like 60 to 80 amps. And because it's not adjustable on this machine, you're basically SOL. Now, do I think that's a problem? No, honestly, I don't, because again, it's a portable TIG machine. And so what if you burn up a few seconds of argon more than you should? I don't really see that as an issue. Now, if it was adjustable, that would be better because you could dial it down to where you're not wasting as much argon. But again, the alternative is lift start with a gas valve, which you would see in cheaper like Amazon specials, and I guarantee you'll forget to turn the gas off far more than you do. So you're going to waste more with that kind of setup. But yes, the gas flow is, I would say, excessive. But hey, it beats, like I said, the gas valve situation. Other than that, let me go and get some thicker steel and do some welding on that. So that I had no problem TIG welding stainless, which again, it doesn't take much of a TIG welder to do a good job on stainless, but the arc was real smooth at slow inputs. Anytime I was fast on ramping up or down the amperage, it had an audible and visual like tick to it because it's probably not, it's like jumping in 2 amp increments. It's not really a big deal, but when I'm used to higher end TIG machines, I don't see that with them. But again, this machine does it. And believe it or not, the TIG 200 ESOB, when giving it amperage, it doesn't. However, when letting off, it does the same thing. So this isn't something that's like, oh man, it's terrible. A lot of machines do this, but higher end ones, you're not going to find that. But I like the way the TIG arc is. It's pretty decent. And the foot pedal, for as weird as it looks, it actually kind of works pretty decent. Let's take a look at that foot pedal. So here is the Vulcan foot pedal. This is the Lincoln foot pedal. This is the Miller foot pedal. I have not seen this particular foot pedal with any other machine other than Harbor Freight's. If you know that this is used on other machines, let me know in the comments. But it's kind of unique and likely Chinesium. Now, there's kind of some interesting things. One, I'm not a big fan of the heel hook. Like, I don't like that on the Miller style pedal. Luckily, this one, it appears you can just unscrew it and remove it, and now you have a normal foot pedal like the Lincoln. I really like that. And I didn't think I would like this foot pedal because of just the shape and how it felt, but honestly, it works pretty good and is far better than a lot of them cheap ones you get with the Amazon specials. Now, I'll be honest, my favorite foot pedal of all time is the Lincoln pedal. Now, Lincoln doesn't make it. It's actually made by a company called SSC Controls. This is my favorite foot pedal, and the reason is simple. I can put my heel here and then pivot and press it with my heel on the floor. I like that. Miller's foot pedal style, you can't do that because the pivot point is so high. Like, how would you do that? You cannot. Your foot has to be up here in order to pivot this. The problem with that idea is, guess what? Your knee is now 3 to 4 inches higher than it would be here. Therefore, depending like on this welding bench, which is fairly low, I got to lower my seat if my leg is under it, because otherwise my knee's going to hit the underside of this. And I find in a lot of cases, it's uncomfortable to lean over something and use this foot pedal. So the fact you can take this off and it's borderline the same height and the pivot point is all the way back here, I think that this would work more like this overall if I took this off. So I like that design. Now, the other weird thing, which I'm glad I didn't get an arc strike off of that, I thought this was interesting. When you press this down and let off, it immediately cuts the argon flow off. I was afraid initially that anytime you let off the foot pedal, it will stop. However, it detects when you actually had an arc to generate post flow. If you do this just to kind of make sure it's on or something, it shuts off immediately. That's nice. The only downside to that is setting argon flow with this, you'd actually have to get an arc started, let off, and then adjust your meter. So it would have been nice if that would have started at least some post flow so you could adjust your regulator, but hey, it's not end of the world. This is pretty beefy though, and I don't think you're going to have too much issue with this. And at least if you do, you can get a replacement at Harbor Freight. And like I said, I think the design of it is better than the Miller style. Yeah, it's just the control of the machine is a little bit notchy, but I don't think that's caused via this foot pedal. It's just the inherent design of the welder. Well, now let's talk a little bit about how efficient this machine is or isn't. So here's a snapshot of power consumption, and this is on 120 volts, so this is lower voltage, and this kind of covers, when I was welding that nut, the kind of power that it was consuming. So what you need to concern yourself with is the current draw was 12.67 amps, which at a 70 or 80 amp output, it's in the ballpark of that. That's extremely low. And part of that has to do with the power factor. This machine has power factor correction, therefore it's able to maintain somewhere between a 0.92 and a 1.0 power factor, which in simple terms, it's not spitting back reactive power back to the power grid. Therefore, the breaker is only going to see the consumption of power, so what you're actually using with welding, and not the reactive power, which basically can overload breakers on 120 volts. So this would have no problem welding at 60 to 90 amps with TIG on a 20 amp circuit on a 120 volt all day, and it's never going to trip the breaker. Cheaper welders that don't have power factor correction, you'd probably see a 20 to 22 amp loading already at this output, which would almost guarantee over time trip the breaker. And keep in mind, this is TIG welding that operates at low voltage output. Stick, what ends up happening is without power factor correction, you can only get 60 to 70 amps of output on 120 volts. This would be able to get close to 100 or 110 amps of stick output on a 120 volt circuit without tripping the breaker. So that is a really good thing. As far as actual efficiency, since I didn't meter the output and it doesn't have a digital display and I have no idea how accurate that output dial is, it appears to be close. I would say that its efficiency on a rough calculation is somewhere between 82 and maybe 85% of turning input power into output power. The rest of that's basically wasted running the fan and in the form of heat production. So that's in line with what I would consider a good or better welder. When you get into the cheaper ones, like basically everything on Amazon.com that's under 180 amps, all of them, you're going to see a 20 amp draw at this. You're going to see probably 70 to 75% efficiency at best, even though they're inverters, and a much poorer power factor. So overall, this machine, electrically speaking, is very efficient and will be able to do a ton of work on lower voltage. I also tested it on 240 volts and the power factor was 1.0 as well. So that is both in low voltage and high voltage. And to put it in perspective, on 240 volts, this setting would only draw about 6 amps of consumption, 6 to 7. So that's, again, very, very low. And this will run on far less of a generator power than the conventional, cheaper stick and TIG welder, which is good. And also, generators generally don't like poor power factor welders. It ends up screwing up the voltage output and the generator just can't handle it very well. So this would likely run better on a generator than most of them out there. So all good things. So it's pretty interesting that the machine has power factor correction and it is pretty efficient, and that is great news, and that's not what I expected because a vast majority of all welders don't have power factor correction and virtually none of the cheaper ones do. And by cheap, let's face it, this thing isn't exactly in the cheap category at $500-600, but that's great news because, again, that means that it's going to run better on a generator. It means that it's going to run better on 120 volt and not trip your breakers out. And it's also going to run better if you have limited power. And what I mean by that is if you don't have a 240 volt outlet, you can actually get some decent welding with TIG done with this machine, and you're not really that limited. All of that is great, especially if you run on an extension cord. It's also less likely to melt that, so that's a great thing. Beyond that, I think that all you guys want to see if this thing will stick weld, and not only will it stick weld, but will it run 60-10. So I'm going to get some thicker steel and we're going to run a couple passes. I'll do a 70-18 bead and I'll also do a 6010 and 6011, and we're going to run it on 240 volts and see what happens. All right, so got the machine running on 240 volts via my generator. We'll start out with a 3/32 7018. I'm going to set the machine, I don't know, somewhere around 90 amps, or at least what I think is 90 amps. And let's run a bead. That ran really good, really crisp, pretty much peels itself. I could tell the sound of the arc. It definitely is a inverter and not a transformer-based machine, which, well, of course, we already know that. But yeah, that runs really good. I would say that the setting, which again, it's between ranges, it goes from 105 to 70 to 105. That's somewhere in a ballpark of 90 amps. So at least the dial matches what I would expect. Now we got 6011. I'm gonna back the amperage down to about 65 or so, and I'll run a bead and see if it will run this. A lot of inverters have a hard time with 6011. Some of them, most of them will at least run it, and because it takes a little bit more voltage than 7018 and a little bit less voltage than 6010. So let's run a pass and see what this does. Well, as expected, it has a very difficult time keeping the arc lit. If I leaned it way back to get that rod tip closer, it kind of would stay lit, but the welder simply does not develop enough voltage, operating voltage, not open circuit, but the operating voltage. It's probably limited to around 26 to 28 volts, and this guy's around 27, 28 volts to keep the arc lit. So basically that's going to be a struggle to run 6011 with the machine. And I'm going to tell you right now that 6010, it isn't going to work. But I'll up the amperage to around 90. And let's see if it'll even light this and go more than an inch. Yep, that's going to be a no-go. Not going to run that at all, which I kind of expected. All right, well, let's go to conclusion on this. So where does that leave us with this? Well, I got this to say. I am honestly very surprised at the overall, I guess, fit finish, the performance. And the fact that this sucker has power factor correction, I did not think it would. And if you're running on low voltage on extension cords or off a generator, this will do so much more than a welder that does not have that. Case in point, virtually every TIG machine in 160 amp class and less that I know of, all of the Amazon specials, the Everlast, almost all of them that other than by Miller and Lincoln and ESAB, none of those smaller form factors have power factor correction, which means they run like crap on a generator. They run poorly on 120 volts. You get the picture. So I got to say that Vulcan line, again, this is only this welder. I haven't tested any of their other machines, is far better than expected. And no doubt this is a significant upgrade overall over the titanium line. Just everything about it's better, and none of the titanium welders have power factor correction. Case in point, the titanium 225 stick welder, that runs fairly poorly on 120 volt. You can only stick weld at like 70 amps, if that. And again, that goes back to the lack of power factor correction. I've actually tested that machine and it does not have it. Now, is this as good as a higher end machine that's $1,000, like say the ESAB Rogue 200 I have? Absolutely not. The fact that this doesn't have adjustments for like post flow, pre-flow, adjustments more so for pulse, and then for stick, it doesn't have arc force or hot start control. All of those things are nice features to have. This doesn't have it, but at the same time, you're not paying for it. Now, I guess these things sell for like around 500 bucks. And I gotta say, for that kind of money with a decent torch, because the TIG torch it does come with is decent, that's not too bad. And I have under that in this setup. And honestly, I wouldn't be ashamed to use this and to buy one of these and to make stuff with it at all. And the real downside, I guess, to me with it, and it's not really a disappointment because I kind of went into this knowing it, is that no, it basically won't run 6011 and you can forget about 6010. And that's kind of what I've found with a lot of the cheaper inverters. And it's unfortunate because, well, if you want to stick weld stuff, having 6010 is I guess very convenient because it helps with tacking and it also helps with welding rusty material. But if it ran 6011, I would be happier, but it doesn't run that either. So you're pretty much limited to 7018 and 6013, which, let's face it, I would assume nobody is buying this for the stick welding performance. They're buying it for the TIG end. And in that respect, it works really good. I wish the TIG arc was smoother, but again, you have to go up to the $1,000 plus category to really get a better TIG end of things than this. But yeah, I mean, the fit and finish, the cords, there's a lot to like here. I'm actually shocked that they did as good of a job on this as they did. And if you think that this meets the needs of what you're looking for and these are still available, like I said, I don't see them at the local store anymore, I think this would be a great option. And from what I've heard from other people, the rest of the Vulcan line isn't bad either. So if they have power factor correction and other things, nice features, I have no doubt that they are as good as people say. Now, one thing I want to mention before I go here, I find it interesting that the titanium 225 has no issue running 6010, yet this doesn't. And I have a feeling all of the Vulcan line, other than maybe that big transformer machine that's discontinued, I bet none of them will run 6010, including the Omni Pro 220. I seriously doubt that will. So it's kind of funny that in some respects, a cheaper stick-only welder actually stick welds better than something that can stick weld as a feature. But anyways, so yeah, if you got any comments, questions, thoughts on this, you know, your opinion, feel free to share it, but I'm kind of surprised. So guess with that said, until next time.